right, so my name is Matt Batten. We're talking about movement after initial compromise. So we're talking about once you compromise the system, you get a callback, what you're going to do right after. That picture, neither of us have babies. Everyone always asks that. We don't have twins. We're saying that this is our first time presenting, so we're newbies, and go easy on us. Yeah. All right. So there's a picture of Harley and I at my wedding. I just got married in May. Let's see next pictures. Yeah, we've gone to a bunch of talks, and then we realized that a talk like this would be beneficial, and it's what I've wanted to see, and hopefully you guys enjoy it. So again, my name is Matt Batten. I go by Sleep Zero. In Cobalt Strike, that's interactive mode, so it's kind of a double meaning. I don't sleep a lot either, but I also went in interactive mode, which is not good tradecraft. We'll explain that later. So my handle is Sleep Zero. I have a GitHub. What I have on there right now, my most recent one's I call it MrBS.py, but it's a Python script that takes all the logs in a beacon and actually outputs it to CSV that you can upload to whatever you want, like database later. And then I currently work at 6gen. It's under ACO. My team is amazing, a bunch of brilliant minds, and I get to work from home, which is a benefit, and I've never been around such smart individuals who teach me stuff every day. I'm really blessed to work with them. So I'm a husband, again. So there's my wife. She didn't know I was going to put that picture on the bottom right. So that was us at DEF CON this year, her hugging R2-D2, and our wedding in May. I'm a cat dad. It's my cat. I love dogs too, but he's just always angry. I want to put that picture in there. All right.
My name's Collyn Hartley. I just go by Hartley because I'm still currently active duty military, and my parents didn't really know how to spell Collyn properly, so no one pronounces it right. Also, I'm not married, just older brother, two little sisters. Love them very much, take pride in them. Red teamer, penetration tester, and love my dog.
All right, so what we're going to cover. So we're going to talk about initial recon once on a compromised system. Right, so we're talking about after the fact of getting that callback. We're going to talk about lateral movement, so how to move the systems around that network that you're on. Port forwarding, so sending data through an already compromised system to a target, right? You don't want all of it to come from your attack platform. You want to hide where you're coming from. We're going to talk about tradecraft while doing this, and also what tools are being used today, right? So setting the stage, eyes on your computer, stealing your datas. So set the stage, you already compromised the system, and to go into it, so this is a bash bunny, and a lot of people here probably already are aware of what it is. You can do a lot with it. It changes colors when you plug it in, so you'll know it goes from, you can go from red to green or purple. And when you plug it in, you can wait 12 seconds, and then your PowerShell one-liner will run, or it'll go to a web server that you have a payload waiting on that will call to your C2, right? And I mean, that sounds like a lot. And the way, like an example would be a secretary at a company. You show up, Bob's the secretary. Bob, I need access to your servers. Bob says, well, Sarah didn't send me the email. What's Sarah's last name? Sarah Smith. Thank you. Bob, do you have a business card? Yeah, here, thanks. I take a picture. I send an operator in a hotel room. He already has a system compromised on the inside, but we want more. And then they'll end up sending an email, spoofed email to Bob from Sarah, allowing me access to the server room. And it's very common. So phishing emails and physical access, plugging bash bunnies and rubber duckies in, is a common way. Rubber duckies, they're seen as a keyboard, right? It's seen as a keyboard, and it'll run through and like go through PowerShell and call out to your C2 or the web server. And you can actually stop it from just by looking at the manufacturer model of your keyboard. A lot of people don't do that, but that's a lot of work for large organizations. So no one's, or you can disable your USB, right? That'll work. So questions to ask yourself. So who am I, right? So it's pretty deep, but who am I on this network? Where am I? What's around me? Can I get system on the current box I'm on? And an example in this one, when I was taking OSCP, a lot of times I'd pop my own box and not even be aware of it, and I would just run tools immediately. I would get a shell, I would just start running tools and just cause havoc in my own box, and it was, embarrassing. I was by myself, so 30 minutes later I'd be like, wow, I'm an idiot, And like, I hope people admit that here. I admit when I mess up, so, all right.
So going off what Matt said, he posed the questions at the beginning of the talk. These commands that we're going to go through are going to be what you're going to use to answer those questions. We will be showing outputs and screenshots of how we run them, and so you can actually see the output. But some ones I like to pick out because they're my favorite. We have net group domain admin/domain. This will cause traffic on the network, obviously, it's going to query the DC on the network. So, but that is very common because machines, networks, especially enterprise networks, query the domain frequently. What it does, though, is it allows you to see all the domain admins on the network. This is going to be like your end goal. That system is the highest privilege level. It's nice to get, but that's not going to be moving box to box to box to the DC. It's going to be very system moving around the network because you're not going to. It's local. The next one I like is the NetSH firewall show config, because when you're moving box to box, like now with Windows Defender, it can be on each box. There can be multiple firewalls. You'd like to know how they're configured, are they operational, and then what they are, because you can do your OSR on the type of the network, so you can get around through it. So to follow on that, this is just another list, and I hope you guys understand and know that these lists are all going to be commands that we're not uploading, right? They're already going to be built into Windows, built into command line. They have PowerShell equivalents, so you're not going to be doing anything out of the ordinary that someone on command line wouldn't be doing. And these, out of these commands, my favorites are the who am I, because that exactly answers the question. If he was running who am I on his box, he wouldn't have spent that 30 minutes on a test, that it was a test rather than OSCP, wasting time trying to figure out who he is and what he's actually attacking. And then there's the ARP-TAC-A. It's a very good one. It shows you, who the box is actually the target's interacting with and the MAC address, and you can actually do a lot of exfil and get a lot of information from that itself. So like I stated before, these are going to be the outputs of the commands. So as you know, in the command line pictures, we're running shell before. So these commands, the enumeration commands, are within Cobalt Strike. So when you have a beacon on a Windows box, you do actually have to put shell before your command because it's a Windows native command. So like I said, netgroup domain admin/domain. That's, you see that there in the top right. We're big Batman fans, so as you see, our domain admin is Joker. That's going to be our target for the rest of the talk when we use our examples. We're going to go after the domain controller using like the Joker account and trying to accomplish that. Another one I like is a net user /domain, because if you can't always get a domain admin, that's the key to the domain admin. But if you can't, a regular user still can traverse the network without looking extremely suspicious, because especially if you have roaming profiles in a job where you move around a lot and the same desk isn't always open, you will be able to log into multiple workstations within that actual network, and it won't look suspicious. All right, the net start command is a big one. You can run either as a blue teamer or a red teamer. The reason I like it as a red teamer is you can see everything that's starting on that Windows target as it's being booted. But as a blue teamer, if you're looking at it, say we as red teamers, we have a service. It's our persistent. It's named something silly. It's not going to blend in there, but it runs on the start of the machine every day at 7:30 or whenever the machine is actually turned on. You will be able to see that there. You'll see that there. You'll be like, oh, what is this? I haven't seen this before. I've been doing the job for a while. Let's Google it. Oh, it's nothing known, and I might be compromised. Okay. My favorite is also out of this slide is the top left, netstack, TAC-A-N-O. This is a big command for both red and blue teamers. The switches for that, the TAC-A is going to be showing both TCP and UDP protocol. The TAC-N is going to list it in numerical value by port, and the O is going to show you your PID. So as you see here, we have our beacon. We did this with our beacon. So you can see our connection. As a blue teamer, why seeing a connection that is from IP not on your network? That's pretty self-explanatory. You don't want that. It's very suspicious. But also as a red teamer, if you know a blue team or a hunt team is being deployed to location, or if you think you've been compromised, you can see the process ID that your actual beacon is running under. You can kill that and do your cleanup and then kill that and try to get out of there before you're getting caught with your hand in the cookie jar.
All right, so SSH firewall show config, it's on the last slide as well, or show state, but you can actually see Windows Defender, so disabled, right, remote admin mode, disable, but it's just one of the commands you want to run to see what the firewall's configurations are and why. And then a random thing I just thought about that's not on our slides while I was talking was a net help message is actually a really useful net command that a lot of people don't utilize. And I thought about it for my last test, so when you do commands on a Cobalt Strike beacon or even interpreter with Windows, sometimes it'll give you an error code back, and it'll say like 3. You can actually do a net space help message together, HELP MSG space and the number, and it'll actually tell you what the error is. So it's like access denied, which is the most common, right? it's like 5. It's either 3 or 5. I can't remember. But you'll see that, and it's super helpful. So if you get that number back, you do a net help message, you know immediately. A route print, so it's going to show you the pathways, or the route table, right? And then you can actually do a -4 as well, just get IPv4, instead of showing IPv6 and IPv4. See the gateway and everything there. Right, all right. Task list, so it's going to show you all the tasks and the process IDs associated with it. So all the services, like what actually starts, or tasks. And then the driver query, it's going to show you all the drivers on the target. Something cool about driver query, you can actually do like a driver query /F /, I think it's like CO, forget if it's C or not, /O, and you can actually output it to a CSV for like later on post-exploitation. So it can be super useful. And that top one we actually found out from Dave previously when we spoke. I was a speaker earlier. He pointed out that it's actually vulnerable to a well-known exploit. All right. And then going to RTAC-A, also Dave pointed out something really awesome. The first 3 octets in your Mac, you actually will know from the OUI organizational unique identifier, right? It'll actually tell you like what type of, or where, I guess the organization it came from, right? What it specifies. So you get more details that way. And it's going to associate the MAC and the ARP cache, so what's around it. Set is your, it's going to be your environmental variables. So the reason I use set, the actual reason, the truth is I run it because I'm lazy to do system info, and I forget to, find string and then do the specific OS. And mostly I just probably want to know the OS and the domain controller. So I run set, and I just look at the output, and there it is. Schedule tasks with query, FL list, but the /v is important at the end because I actually show you what user the scheduled tasks are running under as. So that's why that V is really important. All right. So disrespect your surroundings. I thought it was funny. No one else will, it's fine. But who am I? So shows you who you are on the current system. Echo logon server. So that shows you your domain controller. But so somebody's going to argue with me or say like, well, that doesn't always work 100% of the time. I'm like, you're right. Yeah, probably like 90%, 80%. And you can actually do a NL test space like get DC name, I believe is what it is. You can do NL test help. It'll tell you as well. But that'll give you 100%. But I run Echo logon server. Echo username will actually show the user as well. So you can see Batman.
Okay, so at this point, we are on a system. We know what the environment is. We know the firewall. We know everything. So now we're going to get into a method of just privilege escalation. I know the talk isn't about that, but we're going to do it once. So because some of the privilege escalation, lateral movement later in the video actually requires higher privilege than just a basic user on the machine. So what we're going to go through here is we're going to be using PowerUp. It's part of a Powersploit toolkit developed by SpectreOps. They've created it. So here we are going to go to Powersploit toolkit. Privesc is what we want to accomplish with this script. We're going to import PowerUp.ps1 and then invoke all checks. It's just a commandlet within PowerUp. What this does, it's going to run on the target system, and it's going to look for any misconfigurations by the system administrator that it can take advantage of in order to actually accomplish our task of privilege escalation. It runs by pretty fast. You just scroll back up to it, but the misconfiguration in this video is it's DLL hijacking. So after we run this, it's really nice. It tells you the abuse function you're going to have to run through PowerUp. It's right tac hijack DLL, and then it gives you the complete path. You don't have to go and guess the path. So you can paste that into your PowerShell command and run it, and then it will populate a beacon for you with that escalated privilege level. So next, you can't talk about PowerUp without talking about Goku, because if anyone's familiar with Dragon Ball Z, that one scene takes at least 13 episodes. So what happens when you do DLL hijacking is first a self-deleting batch file is created with the command you want to import. You can import any command because when you're creating it, you can do tac-c command, and that will allow you to import different commands. So it creates a self-deleting batch file and hides it within a path on the network. After it does that, on the target box, after it does that, it creates a C++ DLL, which then appends to the abuse function that we saw earlier for the right tac hijack DLL. And then once that DLL executes, it calls that batch file, and then that is what gives you your privilege escalation callback back within Cobalt Strike, because that is how we use it on this time.
All right, so we're going to talk about different ways to do remote code execution because we're talking about lateral movement. So WMIC stands for Windows Management Instrumentation Console. So it's a way of utilizing WMI. And that's a command that you would actually put in a Cobalt Strike. We're going to show you Metasploit examples later as well in different ways. So we're not just going to do one C2. So I don't want you to think we're doing that. I thought it was funny, Toy Story, it's in remote code, it's remote. It's fine, but that's the actual command. And we'll see. We're going to show you. So I put turtle.exe on a target, right? I put in system32. This is horrible tradecraft. I would never actually do this. Things I would do instead would be to look what's there already, and then I would add a 32 at the end of it. I would time stomp it probably. I would time stomp another executable or DLL, whatever I put in there, and it would give it the same time. Because everyone, right? As soon as your computer starts acting up, first thing you do is task manager, whatever. Look at the time. What's the most recent? Delete that. Bad. And this would get rid of that, right? So turtle.exe, it's on the target. So in this video, I'm going to WMIC a shell. So I'm on the .12 currently as administrator. The system I've already compromised is called Batten. And first I'm going to remote dir. I'm going to remote dir the target to see that the file is actually there because I don't want to use WMIC and it possibly got deleted already or they knew or maybe I lost a beacon or a shell to that target, and then I just want to call it again to interact with it because I need something off of it. So I go through, I dropped everything on system 32 right there. Yep, there it is. Cool, I know. And then I'm going to go and I'm going to do the command, which, so I do like shell WMIC space node. Node, I'm going to classify the target IP address, right? It's going to come up in a second. You can see I'm on the .12, so the IPs are important. So the beacons are up top. You can see they're compromised. So I'm specifying I want to go to the .8, and I'm calling on that executable that's in the system32 directory. Takes a second. Something to point out. So I set this as an SMB beacon, and does anybody know why I would do an so .8 is a domain controller. So here's a question I guess I give stuff out for, right? Does anybody know why I would use an SMB beacon instead of a beacon for 80 or 443 on a domain controller? Go ahead. Exactly, yeah. I'm gonna give them the book. Yeah, I'll give it to you later though, actually. We'll keep talking, so I'm not walking around. Sorry. But yeah, so like on your domain controller, you don't want to see traffic on 80 or 443. Like, why is the sysad talking out on domain controller? Why is he talking to those systems? Like any blue teamer or network admin would see that traffic and be like, something's wrong with our domain controller. We need to do something. Also, my callback came. I was explaining that. So you see .8. I had a link to it. So it says there it's a binding SMB beacon. So I actually have to link to the target to get access. So if I do 443 like reverse TCP or 80, it'll actually call back to me. I'll immediately get the beacon. Because I did SMB, it's binding. And I think I did a random high port. Yeah, 55655. So the traffic's normal on that network, so no one will know. So the whole reason like my Twitter handle sleep0, which I got because I did that a lot and I got in trouble for it because I just like getting things done and going through. And your sleep and your jitter, you have to space that out as well, which sleep is how many seconds until it calls back. Jitter is plus or minus those seconds. So like a good thing to do, set your sleep to 10 minutes, jitter to 10 minutes. That's still pretty short, but I always keep things short normally when I do this stuff. So now that'll do 10 minutes plus or minus any time between the next 10 minutes. All right.
All right, next we're going a few more ways of remote code execution. Just wanted to preface like the way we're going through these three types is because we just want to show you the first two ways, who we were, how we got the privilege escalation, and now we're taking advantage of that privilege escalation. So the second way we're going to do is schedule tasks. It's just scheduling tasks on a remote system. So the first line up there is schedule task /create. This is obviously creating your task. /tn is going to be your task name. My partner made this slide, as you can tell, because it's mat.exe. The task /tr is going to be the task what you actually want to run, mat.exe. And then sc is going to see when you want to run it. Do you want to run it once? Do you want to run it on idle, on startup? There's many ways you can specify. So you can use this as a method of privilege escalation, persistence, or lateral movement. So the second command is going to be us kicking it off. So the reason we have no time specified at once is because we're just using this for lateral movement. So we're going to kick it off ourselves one time, and then we're going to go in and delete it because for what we want to use it for, that's proper tradecraft. You don't want to leave a task schedule. You can easily query that as a syset. So as I went over the first command, this is us actually going through creating the task itself. Turtle.exe is the executable we want to call. We're utilizing the same executable that we used in our last video. Like I said, we're going to do it once and start time. If you're only doing it once, don't specify time, because in the beginning, we specified a time, it errored out like 3 or 4 times. So we learned that. And then we're going to run this under system. So we can run this as system. So it gives us privilege escalation and lateral movement onto a target box. It completes multiple goals at once.
You have to wait for it to call that.
This is us kicking it off ourselves, the task we want to run, the name of the task we created, and then we want to run it on the .8. Yes?
By not specifying time, but putting zeros, does that mean it executes immediately?
That means it executes immediately once we tell it to. So there is no time. There's no time. It's just we have to add the flag, because when we weren't adding the flag, it errored out. So we went and added the start time flag. We read up on it a little bit more. And when we realized that if we don't specify time, we execute it ourselves. And that gives us the ability to.
And in older systems, they used to use @ a lot.
Okay, as you see, we're on the .8 user system. So that's what we're running as, and we're on the computer Joker, as you see with the enumeration command. It gives you the process ID we're running under, so if we have to kill it at some point, we can. And it's SMB link, so obviously we had to link to it ourselves. The cool thing about SMB links is the traffic is only to the SMB link when you decide it to. So say you have your callback, your HTTP callback set to 10 minutes, that'll call back every 10 minutes. But unless we're interacting with the SMB beacon, it will not call back at all. It'll just wait. It's just waiting for us to tell it what to do, waiting for us to send it instructions. It's not constantly hitting our machine back. The next way we're going to do it is service create, or SC. The first command up there, like our last previous slide, this is going to be service create, the target you want to go to. We're creating MAT again, and it's the binary path. It's the path to our executable. And then we're going to kick off the service ourselves for time of the video, and then delete it off the target. So like I said in the beginning, tie it back to the net start command. If we have it run on startup, this would pop up. It's a service that's starting when the box is originally turned on. So if you want to use it for persistence as well, box turns on, service is created. Hey, we got our call back at the beginning of the day.
That's us not catching our listener we're hoping for. So it's funny.
Okay, this is just a video example. We're going to go in, create the service called I Love Baby Turtles, because we're still using our turtle executable. I believe in this video, we do actually change the path to the temp directory. The reason we use the temp directory is because when you log on, temp directory stood up, and if the box, when the box is like rebooted, turned off, you log off for the day, that's just going to be wiped clean. That's good. That's just good for tradecraft, because say you've always been on as red teamers, I've been on a box before where you don't take all your artifacts, you don't go through every single process of cleanup, and oops, I started a service, I left it on the box, my exe is on the box. What do? Oh, it's in the temp directory. You log off. It's CYA. It does it for you. You don't have to actually go in and do it yourself. So there you go. You see us create our service. I Love Baby Turtles. Bin path, Windows temp, turtle.exe. We're very impatient. So we were just sitting there staring at the computer. You have to wait for it to see the service created before you can go and run. Yeah, let's say service creation success before you can go and kick it off yourself. So we're just sitting there like twiddling our thumbs in this video. So there you see.
Yeah, you said what?
Everything to do while waiting.
Can't say that here.
So that's our service created, and then this is our command to actually go kick it off, right? The target, service create the target, obviously we'll start the service, and I Love Baby Turtles because that's what we named it. This time we were pretty quick to link, opposed to our first video when it came to doing the SMB beacon. This one, we were actually so quick, it didn't kick off the service. We tried to link to it 3 times, it didn't work. By the 4th time, the service actually kicked off and running on the machine. So you see the child beacon, there's our system callback on the domain controller, and there's our process ID in the top right. And just to prove it to you, well, now we're going, that's just to prove that target machine.
We delete it.
Very last, we're going to go in and we're going to delete the service I Love Baby Turtles, just so no one can see that when they're running a start on their box. So like we said before, we're not going to do all Cobalt Strike. We're going to do different C2 because we know some people don't use that. Some people use Interpreter because it's free, open source. So we're going to go do Psexec, which is nice because most of what we're doing is already built into Windows or part of a sysinternal suite. So it's a Windows sign executable. So we're going to show you how to use that VM interpreter to move to a target on the box on the network. So first, we're going to post. We're going to paste the module we want to use, SMB, Psexec. One thing to do with interpreter, what I really like, is your show options. It's going to tell you what you need, what you want to add. So it already has 445 because that's what Psexec works with. And our host is, we're going to set the our host. We set the our host wrong the first time. So we were going to target our own box. So that's why we like to add that in the beginning of the talk.
I typed that. Yeah.
He is the one who typed that. And then, so you don't have to use the username and password, but we had it. So at this point, why not use it? Okay. Show options, because sometimes not everything is going to populate for you. So show options before you exploit it, so you know it's going to run properly and everything is populated. You can type run or exploit, and they will accomplish the same task within. As you see, TCP handler is our .6 is our attack platform. Don't use port 4444. We didn't change it because this is the demonstration video, but do not use that port. It's what Interpreter uses by default, obviously. It's terrible tradecraft. As you see, our session is open. We're connected to the .8. There's the port that it touches on the .8. And just for proof of concept, we get you ID, we're system. We went into shell, so we're interacting with the box via command shell. We have the host name, and so just proof of concept, we are on that target from our .6.
All right, so WinRM, it's another way to laterally move. It's open on those 2 ports, 5985 and 5986. 5986 is encrypted. You can send encrypted traffic over 5985. A lot of people argue that randomly for some reason. That's great knowledge to have, I guess. And so Windows Server 2008, it's WRS, right? Windows Remote Shell. There's a command at the bottom. We don't have an example or a video example for WinRM. But I love this, I don't know, meme, I guess you would say, your picture, but Windows Server Security, keep out or enter. I'm a sign, not a cop. It's very true. It makes me happy. It's random, but all right. So remote registry, this is another way to establish persistence and move laterally, right? And we're actually going to create a registry key remotely to the target, and then we're going to kick it off by rebooting it. You'll see next. So I put go.exe on the desktop, horrible tradecraft, but it's just so you guys get a pretty picture I want to show you. And then, so in the services, it actually has to be enabled, right? Remote registry, that has to be enabled in the services for you to be able to do this. And there's a dude running with a register because I like gifts. All right, so we're going to use an interpreter. All right, so currently, I have a shell, right? If you look at it, so my attack platform, my attack machine, the Kali box is a .6. I have a shell back from .10, and I believe I'm going after the .12, okay? So that's kind of confusing. So I'm .6. All right, this is my shell with the .10, and I'm creating a registry key using the host name batman.com, which is the .12. Okay, so I create the registry key, I call it wolf, and I'm calling on goat.exe, which is on that desktop. And after I created it, it asked me to overwrite it because I did the video like a second time, third time to make it pretty. And then I shut it down remotely. So that's through command prompt, right? So you do your shutdown /m. So you're saying the system batman.com techr ft0. So you're saying time now. So that's you restarting your box remotely. You can do it through PowerShell as well. And so then the box reboots on the target. So when the box reboots, it'll actually kick off the registry key that we just created on it, right? So the registry key stores all the Windows configurations and stuff, and that's good to know. It takes me a second. I'm going to show you. So I kill the listener and I restart it because I use the same payload that I originally used, which is going to call back to .6 on the same port, which is dumb, but that's what I did. So I'm waiting for the callback from the .12. So I restart my listener. I'm going to show you the attack machine and what the user sees. Which, like, some people, they don't, or haven't worked with this before, like, what? The user doesn't see anything. There's no crazy pop-up for lateral movement. Like, there's not. So there's a user, go.exe, and watch the other side. You're going to see my shell pop. And it should be for the .12. Boom. There it is. Yeah. Thanks. Good stuff. It's exciting when that happens on a real operation. It's super funny. And yeah, gives you that high. Yeah, this is just me showing you that's the .12 on the target, and that's what the user sees, nothing happen. That's all I'm going to do there. Cool. So DCOM, I'm not the subject matter expert on this, but I didn't feel like it was okay for me to do this talk without mentioning it. Matt Nelson documented it, and there's a lot of resources out there, and it's really awesome, and it's pretty recent, but I'm not going to try to pretend to you like I'm smart enough to explain it really detailed, all right? It's honest. Go ahead.
So next, we're going into Mimikatz. I'm sure like everyone in the blue world and red world has heard of Mimikatz at a certain point in their career, whether they're dealing with HPSS, AV, what it is. There's tons of things for it. We're going to go through a method of being able to run Mimikatz and utilize going to LSAS without having to put the executable on the target box itself. So nothing will flag. We're just using, like I said before, Windows Sign executables to accomplish our goal. So in the top left, you're going to see procdump.exe, so process dump LSAS, because that is what Mimikatz is going to take advantage of. You see our procdump file in the top left, that's what we're moving on to the target. Give dump is the mini dump, that's the result of the target. And then Mimikatz.exe is being ran on our Windows attack platform on the right-hand side within command line. And the result is going to be the clear text passwords, SHA-1 hashes, and incidental hashes last reboot. Me and Matt actually, this is kind of like our first test together. So we did this on our first test together, and he kind of has a story that will tie in more and explain more on what happens with Mimikatz.
So it's a real world example. It was really cool. First time I got domain admin, I'll never forget. And it was utilizing this. And a target, it was a file server. So I got default creds. I knew it would work. I got on a system. I saw a file server that hadn't been restarted in probably like a year. And then I knew that domain admin most likely logged in that file server, right? So his creds are stored in there in the LSAS. I couldn't get a remote code execution like we were showing stuff earlier. I couldn't get that working. So I actually RDP'd through RDP, which is pretty crazy. I thought it was really dumb, and I was just like, I'm going to do it. When I waited till the guy I was with wasn't sitting next to me because it was embarrassing. But I RDP'd through RDP, and I mapped my share. And then procdump is a Windows, it's Windows Sign, so it's not going to flag. And I moved procdump onto the target machine, the file server, ran it against the LSAS, created my mini dump file, right? And I pulled it off the target, and I went back through the RDP sessions, through the shares, and pulled it back to my box. And then I sat there for 3 hours and realized I kept running the mini dump against the dump file I had to get the creds, and 3 hours went by and I couldn't get it working. And architecture matters on the target, and I didn't realize that. So it was an x86 target, and I had a 64 Kali attack platform. So I actually had to move the dump file to the x86 machine. I just did XP, I think. And then I ran Mimikatz against it and got clear text creds. This is my first domain admin. It's pretty awesome. All right. So responder. So you can't not talk about responder with lateral movement. It's an amazing tool, and it blew my mind the first time I used it. My first Python script I made, I actually automated a post or a blog by a byte bleeder, and it was responder to crackmap exec to NTLM relay, and I used a PowerShell one-liner that I obfuscated with invoke obfuscation, I believe, which is a great way to obfuscate your PowerShell one-liner, right? Other than your own ways that no one knows about. But so LLMNR, it's a link local multicast name resolution, right? It's a mouthful. NBT and S, that's NetBIOS name server. And the main difference that you want to get out of those two is NetBIOS name server is IPv4 only, and that's really, they're pretty much the same other than that. I thought that was a funny GIF, but no one laughed. Yeah, so it's fine. So, so this is Responder running on a target network, right? So I run Responder, and I'm going to show you that on the target machine that I want, he's going to go to food. Food is not an actual network resource, so it's not in DNS. So when he queries he's like, hey, I want food, since I'm going to be running Responder, I'm like, hey, that's me, like, come here, and then he'll say, here's my hash, because on the network, you're not just passing everything in clear text. It goes to an algorithm, it's hashed, or you might not know that. I shouldn't assume everything. So it goes through an algorithm, and it creates a hash for the user, and then it actually passes that. So I'm like, hey, man, that's me. Boom. Username hash, right? Just in a way, way to stop that SMB signing. You can go into that, and like everyone's gonna be like, yeah, that sounds awesome, but everyone who has an actual network, has legacy systems, and you need Samba, so you can't really turn on SMB signing, but whatever, sounds good. So runfinger.py is in the Responder's tools folder, and it'll actually show you the OS domain and whether or not SMB signing is on or off. Because next thing I'm going to do after this, I'm going to show you how multi-relay works. So I'm going to put it all together. I didn't want to just talk about Responder and not show how to get a shell utilizing it. You could pull that hash from the previous slide offline and crack it as well, right? Which everyone loves to try to do. So there's the output. So my domain controller has SMB signing on. The other two don't, right? All right. Multi-relay. So we put this GIF because since we're doing this talk, we're going to pretend like we got on our first try. It was not true. It took a little bit, a few hours, and we realized what we were doing wrong, like what idiots we were, and we got it working. So it'll actually relay your hashes that it collects to a target to get a shell, or you do commands and stuff too. But this is it all coming together. So in the beginning, it happens pretty quickly, but you're going to see me edit the responder.conf file. So the configuration file for Responder, right? Multi-relay uses the SMB and HTTP to pass the hash. So I have to actually turn HTTP and SMB off on the responder.configuration file. So you're going to see that. So there's a target. It's a .12, Batman again. And I'm the administrator on there, right? So that's the target. And then you'll see I turn off HTTP and SMB because I have to use it for multi-relay. Control-Shift-T in Kali in the terminal will actually give you another side terminal like I have. Super useful tip I love. I don't understand people that can do a million terminals, so I just do Control-Shift-T and go through it. But so in multi-relay, you can specify the target. So you do TAC-T in the target. You can do a whole class C, or you can specify a whole class C, or you can just do one target. You can specify what users that you only want to pass the hash as well. So for this one, I did all users, and I did one target. So I'm saying any user that passes a hash on this network that is vulnerable to Responder and me poisoning it, I'm going to pass to this target to get a shell. So you'll see me, I'm running on the interface, I'm listening. I think for this one, I did hi everyone. So he's trying to access a network resource that's not there. So hi everyone. Okay. The Responder runs. There's my shell. Yeah. All right. Anyways, you can do a bunch with it at that point. You can pass off to Interpreter, Cobalt Strike, wherever you want. It's really useful.
Next, we're going to go over port forwarding. This is a good way to kind of obfuscate your traffic, right? Port forwarding, for the most part, is funneling your traffic through a callback you already have, so no one will see your attack platform. So like we've been doing, we have our .6 is our attack platform. We're going to be funneling through either the .12, .10, or .8 to get to another one of those boxes on the network, so they can't see any of the traffic from our .6 originally. The different types are SSH, Metasploit, P-Link, proxy chains. The two we're going to talk about today are Metasploit and proxy chains, because those are the two of the most common C2s that we see out there. Okay, port forwarding with socks. What you're going to see on the right is there is a file you have to edit on your Kali box. It's proxychains.conf. You're going to have to make sure that the IP is your host box and it matches up with the port that you're going to create the socks proxy on within Cobalt Strike. So as you see, we have port 8000 in our proxychains.conf file, port 8000 socks command on Cobalt Strike. Just to demonstrate this is a quick video. We're just going to do an nmap scan. So proxy chains, you have to type that before you want to do the command and the traffic you want to funnel through your beacon. So we're just going to do nmap. We're going to scan a target that we don't have a beacon on through and push that traffic through the beacon. So the ports we're going to scan for, just for demonstration, are 22, 33, 89, and I believe 445. That's going to be the target IP we're going to want to scan, and then you'll just see the output quickly run, open, close, so you do get actual results back.
And one thing I want to point out from earlier, I forgot to mention, so for Responder, a real life incident as well, or something that happened, companies will have switches and they'll say port security is enabled, and we unplug that Ethernet into the switch, it'll lock down, which most likely probably won't after like 3, but if a different device plugs into that, it'll know due to MAC address, right? But any good operator or person has to do, or hacker, whatever you want to call them, they just unplug the Ethernet from the switch, plug it into their own laptop, run TCP dump or Wireshark, clone their IP address and MAC address. Now they plug their laptop into the same Ethernet port, and they're that device they unplugged. And a lot of people that blows their mind. I visit a lot of places where they don't understand that. And then you run Responder. So I'm on the network, and now I'm running Responder. I'm just collecting whatever hashes as they go across. I wanted to mention that. I forgot to earlier. Sorry.
Like I said, the second demonstration of port forwarding is going to be through Interpreter. The main thing a lot of people with this is creating your payload from Interpreter, right? We used MSF-Venom of the payload versus TCP. The L host is going to be your attacking host, your listening host, sorry, and your L port is going to be whatever you want your listening on, right? F is going to be format, you want it to be executable, and then you output that payload to the document or the executable name. That's very important, and then you have to make sure we did this side by side because we start your multi-handler, which is your listener. All of that has to be the same as what's in your payload because you will not be able to, if they're not the same port, not the same IP, obviously it's not going to catch your callback once you execute. So what we showed here is we tie this back to physical access. So if you have someone who can get onto a computer who's very skilled to get onto a computer, infiltrates the actual company itself, we can host a payload using Python, TAC-M as a module, simple HTTP server. And what that does is it'll host whatever files are in the directory you run the command from. So you have your insider threat in the network, browses to your IP address on that port. As you see, cat.exe shows up. You see the GET request, and they can go ahead, download, and execute that on the target host.
Cool.
So first we're starting our multi-handler. We ran our listener, executed cat.exe on the target box. Just proof of concept. It's always nice to do the get UID, shell, who am I, host name, just so you know who you are, where you are. Make sure what you're targeting is in scope of your assessment. And then last is the actual getting to the port forward add. So you're going to run the port forward add. Don't run this within shell. Run this within your interpreter session itself. Port forward add, you have your L port, the port you want to go after, and then TAC R is going to be the host you're trying to attack. So we tied this in with that scanning we did earlier through our SOX proxy. We saw 445 was open. So exploit like Eternal Blue that can go after port 445. That's how you get it there without seeing it come from our attack box itself.
So an example would be just attacking yourself. It blows people's mind the first time you use port forwarding. For me, it blew my mind where I attacked a machine and I forwarded my port 445 to a target port 445. That was the first time I learned it. And then you exploit so in your Metasploit or interpreter session, you're actually, or I guess Metasploit framework, you're actually saying, I'm attacking myself. That's your R host, the target, right? You're saying you attack yourself on that port that you forwarded. So if you didn't forward that port, you're just actually attacking yourself. So it's kind of a mind freak thing when you first do it. So can't talk about lateral movement again without Bloodhound. Spectre Ops guys are amazing. And I just thought it was funny having a dog's head bouncing with a Bloodhound. But there's us connecting our Neo4j at the bottom left, right? So Neo4j is a graphical management platform. So it just makes pretty pictures for all that data that you collect utilizing Bloodhound. So you start up your Neo4j. It takes a lot to configure it, but they have a really good write-up. So let's go to that and read it. And then, so this is actually me running Bloodhound through Cobalt Strike. So when I run it through Cobalt Strike, it actually drops a .zip on the target. And that .zip, I would then pull back and upload the CSVs into the Neo4j console, right? And then it'll give me the pretty picture. Which is, the issue with that is you're dropping a file on the target. So if you drop it on the desktop and users on there, they're going to see it. And a lot of operators aren't aware of that the first time they utilize the tool. And then something really cool I actually learned not too long ago was that you can do, it uses like REST API, but you can actually do a reverse port forward through Cobalt Strike. So you reverse port forward, like it's like 7474 or 7878, I can't remember. But you do reverse port forward for that port, and then when you run it, you do like invoke Bloodhound, right? And then it'll be like tac URI, HTTP, :127.0.0.1, 7878, quotes, space tac user quote, or :pass, space, and you put the username and password to your Neo4j. And it'll actually take all that data and just pipe it into your Neo4j without dropping the zip on the target. So it's really cool and super useful, and I thought it was super badass. So, anyway. And that's what it looks like, the output, right? Green are users, yellow is the groups, and the red's the system that we compromise. So this is an example of the shortest path to the high-value targets. And it just makes it all pretty for you. So you can click it, and it'll actually tell you the pathway you need to go. And then I didn't want to say all this data and put it all out there without giving the references where a lot of this material came from. People smarter than me in specific areas that do their work are the ones that really came up with this. And then I just use their tools, and I want people to know about them and talk about it. And we're going to post all this later as well. So these are the people who influenced me a lot and who I follow on Twitter, and they might not even know it. So I creep on them a little. They're all awesome. And that's why I imagine a hack on the network, which is like funny to me. I love Dwight from The Office. He's my favorite. So I just imagine, like, because you're just pretending to be a bunch of different people. It's pretty fun. And then if you enjoyed this talk and like to know more, these slides will be available. We're not sure we're going to post them yet. I'll probably put them on my GitHub and other things later. And then obviously this video is going to be available. Feel free to message us on Twitter. I'm super interactive. I love collaborating. If anybody has any cool ideas, I write in Python. I'm currently writing some like implants and stuff in C. And I'm trying to create my own C2 right now. Just like super, that's like on the side fun. But if anybody wants to like work with me on that, it'd be pretty cool. If anybody's interested. And yeah, that's it. Does anybody have any questions?
Yeah. So earlier when you were showing the WMIC commands, what are some artifacts that are left on the system that those under responders can look for? And determine what exact WMIC command will run.
You got it? No. You have that one? Can you ask again? Sorry. I thought you were going to answer that one.
For the WMIC commands that was shown on the slides, are there any artifacts that are left on the endpoints so that defenders can piece together what exact commands were executed?
With WMIC WMI commands that are the artifacts are left behind from WMIC. Off the top of my head, I do not know. I'd have to actually look into that. I know like there's probably a lot of blue teamers out there. For WMI itself, I do not know the artifacts that are all left on the target. That's why like normally when I'm doing my red team assessments, I have Google right beside me. Before I throw something, I Google that. So for WMIC itself, off the top of my head, no, I do not know.
You can shut down, I mean, you can lock down WMI pretty well. But as for like tools, like instrumentation, like how to set up your configuration and like monitoring like processes and stuff, that's a lot of information that we think is pretty hard on red team, and it gets super deep in a blue team. Sorry.
Thanks.
Yeah, man. Anybody else have any questions?
No, but I think I can answer part of his question.
Go ahead, man. Please.
4688 in the event log, and if you turn on command line auditing, that'll
Yep.
be the actual command that was executed. Installing the SysOn with the Miller split config. Miller split on security,
Yeah. That's awesome.
those are probably simpler tools.
I'm super happy to hear that. I'm actually packaging SysOn for deployment across enterprise right now.
Awesome.
Nice.
Actually, thank you for that. Now I
Yeah.
don't have to Google anything. I can.
All right. Does anybody have any other questions?
Yeah, I'll give-
No? All right. Thank you for coming, everyone. Sorry.
Thank you. Appreciate it.